Let's look at another example of solving a triangle within the side-side angle case. This time we're given angle A is 40 degrees, side A is 80, and side B has a length of 10. So let's start by drawing our picture, our triangle. Again, I'm going to draw my standard triangle. Horizontal bottom side, slanted sides going upwards to meet at the top. I always put the known angle in the bottom left corner just to match the illustrations that I have. So that means angle A of 40 degrees has to be in the bottom left corner. Side A is opposite that, which is 80. And side B, I'm going to put in the top left just to match, again, match the illustrations that I've used. That means angle B has to be the bottom right angle. Angle C has to be the top. And then side C is the bottom. Okay, I'm just, again, doing that to make sure it sort of fits the illustrations that I've looked at. All right, so again, if we look at the information we have, just to verify, we're given the angle and two sides. The angle is not between the two sides, so that is definitely side-side angle. Okay. Next, if we look at the two sides, the opposite side of 80 is less than the adjacent side of 100. And so that means that we don't have to worry about the situation where you have one solution because the opposite side is longer. Okay, this time it's shorter. So that means, again, we could have no solution if it's too short. We could have one solution if it's a perfectly 90-degree angle, which won't happen. Or we could have two solutions if it's just right. Okay, so a little Goldilocks action here. Again, to figure out how many, whether we have no solutions or two solutions, we need to compute the height. So we draw our vertical line from angle C down to side C, and that creates a right triangle. And we can find the height by taking the sine of 40 degrees, which will equal the opposite side h divided by the hypotenuse of 100. And so if we solve that for h, that's going to be 100 times the sine of 40 degrees. And so 100 times the sine of 40 degrees gives us a height of 64.28, roughly. Okay, so what we should observe here is that the height of 64.28 is less than the length of the opposite side, 80, and that's less than the adjacent side of 100. Okay, and so again, this is that Goldilocks situation. This is where we're going to end up having two solutions, and we need to solve for both of them. Okay, so I'm going to redraw my triangle, but I'm going to draw it twice. Okay, just so I have one for each solution. So first triangle is going to be the exact same thing. So angle A in the bottom left corner is 40 degrees. Angle B is unknown, but it's in the bottom right. Side C is the bottom. Side A is top right at 80. And side B is top left at 100. And C is the top angle. Okay. The other triangle would happen if I took side A and swung it towards the angle A. Okay, so this is side A, and so is this. And because they're equal to each other, the angles in the bottom are also equal to each other. And so that's how we get this second triangle. So I'm going to draw, again, basically the same triangle, but I'm going to do it sort of with mostly dotted lines here. So A is 40 degrees. We do know side B is 100. And I know side A is 10. Well, B is way out here on the bottom right. We can find that, but it's equal to this measure here. So I'm going to think of this as B1 as that acute angle, and then B2 is going to be this obtuse angle here. Okay, and so I know B1 and B2 are supplementary. So the sum of B1 and B2 has to be 180 degrees. And we'll get to that later, how we use that, but just kind of store that in mind right now. Okay, so let's start with our first triangle, and we're just going to use law signs for all of this stuff. We just have a lot going on here. So we have sine of A is 40 degrees. So let me write my proportion. Sine of 40 degrees over side A, which is 80. That has to equal the sine of B. But again, we're thinking of this as B1 now, over side B, which is 100. Okay, and so we can find angle B by cross multiplying and dividing. So we're going to have 80 times the sine of B1 has to equal 100 times the sine of 40 degrees. We divide over the 80. They cancel there, and then we're going to take the inverse sine. So B1 is going to be the inverse sine of 100 times sine of 40 degrees over 80. And that gives us that B1 is equal to 53.46 degrees. Okay, so we know angle A, side B, and we now know angle B1 is 53.46 degrees. Okay, so all that's left is finding angle C and side C. Finding side C is pretty straightforward because angle C. To find angles, remember the sum of the three angles has to be 180 degrees, which means C, which is the one we're trying to find, is going to be 180 minus angles A and B. So we have 180 minus the 40 degree angle A, and then minus the 53.46 degree angle we just computed. So angle C has to be 86.54 degrees. All right, and the last piece to find is side C. We can now set up our proportion. So we have the sine. We'll use the A's again as our main one. So we have the sine of 40 degrees over 80 has to equal the sine of angle C, which is 86.54 degrees, over side C. Again, cross multiply and divide, you get C has to equal 80 times the sine of 86.54 degrees divided by the sine of 40 degrees. And that gives us that side C is equal to 124.23. Just to keep things straight between the two triangles, just like we did with angle B, we called it B1. It might be helpful to think of angle C as C1 and side C as C1, because we're going to have to deal with another angle B, another angle C, and another side C. So we'll use the second triangle, we'll refer to those as B2, C, and C2s. Okay. All right, so that's the first triangle. And again, the first triangle is always going to result in an acute angle for the first value you find. The reason of that is because when you compute an inverse sine, you're always going to end up with an acute angle. That's due to the restrictions, the domain and range restrictions we had for inverse sine functions. You're always going to end up with an acute angle. Okay, so now let's look at the second triangle. Okay, so I already mentioned this a few minutes ago, but we know that we have this isosceles triangle here, and that means the sides are both 10, and it means the angles in the bottom are both equal to each other. So we just found B1. Okay, that's what we did when we found our inverse sine. Well, B1 in the bottom right has to also be equal to this acute angle next to B2. And so that means B1 plus B2 has to be 180, which means B2 is going to be 180 degrees minus B1. And B1 was 53.46 degrees. So we get that B2 is going to be 180 minus 53.46, which is 126.54 degrees. So B2 is going to be an obtuse angle every time, because B1 is always going to be acute. Okay. We now know angle A, and we know angle B2, which means we can find angle C2. And that's because, again, the sum of our angles has to be 180 degrees. And so angle C2 is going to be 180 minus angle A, which is 40 degrees, minus the B2. And we just found B2 was 126.54 degrees. And so angle C2 has to be 13.46 degrees. All right. Last thing we need to find is side C2. And so we can set this up just like we did for side C1. So we will have the sine of 40 degrees over 80. And I'm using the same values there because those were the given values for angle A and side A. So sine of 40 degrees over 80 has to equal the sine of 13.46 degrees, because that is angle C2, and that is paired with side C2. So if we cross multiply and divide, C2 is going to equal 80 times the sine of 13.46 degrees divided by the sine of 40 degrees. So that gives us that C2 is equal to 28.97. Okay. Again, just to kind of verify that our proportionalities remain true, look at the first triangle. For our first triangle, angle C is the biggest at 86.54 degrees, and its opposite side, C, is the longest at 124.23. Okay, angle A is the smallest at 40 degrees, and side A is 80, which is the smallest. So our proportionality remains true there. If we do the same thing for the second triangle, we know that the smallest angle is angle C. That was at 13.46 degrees. And side C is 28.97. That's the shortest side and the smallest angle. And then again, angle B2, which is 126.54 degrees, is the largest angle, which corresponds to 100 for the longest side B. Okay, so our proportions do match for both triangles. Okay, and both of these triangles match the given information that we had, the 40 degrees, the 100, and the 80.